So we're asked to evaluate this integral. Use a formula to solve it first, then prove that formula. We have that integral of cosec x raised to power n dx is always equal to minus cot x cosec x raised to power minus 2 over n minus 1 plus n minus 2 over n minus 1 integral of cosec x raised to power n minus 2 dx. So that's the formula we are going to use to solve this. So we have that our n here is 5. Cosec x raised to power 5 is now minus cot x cosec 5 minus 2 is 3 over 3 minus 5 minus 1 is 4 plus 5 minus 2 is 3. 5 minus 1 is 4 integral of cosec x raised to power 3 x. So we're going to do it one more time because we're going to evaluate using that same formula. N here is 3. We'll repeat this one. So integral of this, we now use this, which is minus cot x cosec 3 minus 1 is 1, 3 minus 2 is 1 over 2 plus 3 minus 2 is 1 over 3 minus 1 is 2 y 3 minus cosec. So integral of cosec is ln cosec x minus cot x plus k. Do you get? We're now left with integral of cosec, which is ln cosec x minus cot x. So let's look at the option. You can factor minus half. So if I factor minus half, so I'm left with cot x cosec x here minus ln that. So our answer is option A. A is the best option because this is. So the answer is option A. Let's now prove the formula. Okay, if you ask to evaluate this, we need to use integration by parts. So let's call this, we can split this as cosec x raised to power n minus 2 cosec squared x dx. Yes, so we now have integration by parts. If you could remember that integral of u dv is uv minus integral of v du. So in this case, we'll let u be cosec x raised to power n minus 2 y dv will be the remaining, which is cosec squared x dx. Do you get? This is dv, why this is u, as this formula. So we can use it to get u and v. Using, we know u, we can use the two to get v and du. So if I differentiate this, I have n minus 2 cosec n minus 3x times the derivative of cosec is minus cot cosec, which is now equal to minus n minus 2 cosec n minus, that's x cosec x raised to power n minus 2 minus 3 plus 1 is this cot x. Yv here, if you integrate this, is now minus cot x. So let's now substitute. We have integral of this cosec x raised to power n is now equal to our u is this, our v is this. So I have minus cot s cosec n minus 2x minus integral v is minus cot x y du is this. So I have, if I multiply this and this is now plus, I have that's that same plus that this is square. So I have cosec n minus 2 cot squared x dx. So we are still going, we'll repeat this. We'll bring out the constants. We now have integral of cosec n minus cosec s raised to power n minus 2. So we need to change this cot to cosec, which is cosec squared x minus 1 by Pythagorean identity. 1 plus cot squared is cosec squared, so cot squared is cosec squared minus 1. So we'll repeat this. Minus, okay, let's just open this. Integral of this times this is cosec x raised to power n minus cosec s raised to power n minus 2 dx. So what do you notice? I have cosec x raised to power n here. I still have it here. So what do? I'll move it. That's this times this constant will multiply both of them. This goes over to the other side. So let's repeat the first one. Why this one moved to be plus n minus 2 integral of cosec x raised to power n dx. You get, I've moved the product of this and this to the other side to be plus of that same thing. Why what is left here is minus cot x cosec n minus 2. Why this minus times that this is plus n minus 2 integral of cosec x raised to power n minus 2 dx. So what do you notice? I'll factor cosec x raised to power n. If I factor it, what is left is 1 plus n minus 2. And 1 plus n minus 2 is n minus 1. Is equal to minus cot x cosec x raised to power n minus 2 plus this integral of cosec x raised to power that. So finally, what are we looking for? We are looking for the integral of what? So we'll make it the subject of formula. Therefore, integral by dividing by n minus 1. So if we divide both sides by n minus 1, so I have minus cot x cosec x raised to power n minus 2 over n minus 1 plus n minus, sorry, this should be n minus 2. This n minus 2. Because if you multiply, see, this, so sorry, that's a mistake. N minus 2 over n minus 1 integral of cosec x raised to power n minus 2 dx, which is the formula that we use in solving this. Check that the same. So using this formula makes the solution easy. So if you can memorize, it's a plus to you. But I use it always. Thank you.